Hello everyone. In this video, I'll be explaining about the minimum swaps 2 problem inside the array subcategory inside the interview preparation kit. So if you must have gone through this problem, you will be knowing that in this problem will be provided with an input set in which the first number depicts the size of the input array and the subsequent elements depict the elements that are in the input array. So as you can see over here, the sample input that we have, and what we need to return is the number of swaps that is required to sort this array. So as you can see in the explanation, that after we swapped 0 and 2, the elements at the index 0 and 2, we got 1 3 4 2, and after swapping elements at position 1 and 2, we got this, and after swapping elements at position 1 and 3, we finally got the sorted array, and hence we have to return 3 from the function that we made. And similarly, we are even given with sample input 1 and sample input 2 that you can just go through from this HackerRank problem. And what we are supposed to do over here is to find the minimum number of swaps that would be required to sort an array. So let's begin with what would be our implementation for this case. For that, I've just written a pseudocode in front of you. The first thing you need to do is understand this in order to there are multiple approaches and I would first recommend you to go and try solving it, and once after trying only try to if you got some solution or if you're looking for some better approach, then come back to this video and just look over here, because the first thing that is required to solve coding problems or coding questions is actually giving a try. Until unless you know how to frame algorithms, you cannot solve a coding question. So that would be my recommendation, and I hope you must have gone back and come again to this video. So I'll be continuing from here. As you can see, I was speaking about this input, this pseudocode that I've written over here. We have initialized a variable swaps, and we have initialized it to value 0, in which we'll be storing the number of swaps that will take place. And you can see over here, I've written here that we'll be looping from the index 0, index by index I mean that from the first index, that is 0, till the second last element. And I'll come in a while back to this, like why we are just going to the second last element and not exactly the last element. I'll just be explaining that. So first, what we are checking, if that element is equals to the index, then do nothing. And the reason for that is, just consider if we are given an array that has 1 2 3 and 4, and right now I'm not writing the basically I'm not writing the index, I'm writing the position, that is 1 2 3 and 4, because you know index always starts from 0, so I'm just writing the position. And what I mean by this statement, when element is equals to index, is when this element that that is 1, when it is equals to its position, then we need not do anything. It is already sorted, means it's already in the right position in its sorted array. Similarly, you would see that it will not work for any of the any of the elements over here, and at the end we are going to return swaps, which will be by default 0, because it didn't have anything to do over here. But if just in case if we have some element which is not equal, for instance, if you would rather have over here 2 and 1, then we will definitely need to be doing something in order to make this array sorted. So what we will have to do for that, we have to go inside else and look for that. What I have written over here is loop from index plus 1. Again, from this I mean, just in case if you are having problem with my pseudocode, like what do I mean by index, that is here I mean 0, and here also I mean 0. Basically my index means 0. You can even write take it as 0 only, that is something I meant over here. So I'm starting from index plus 1 till the last element, and coming there again, here we went till the second last element, but here we are going till the last element. What we are going to check now is, index plus 1. Right now, first it checked whether 2 is equals to 1 and it got no, and that's the reason we entered else. Now it is checking from index plus 1, that is right now, if just think j is our variable of the second loop, we are starting from 2 and from this position, and we are checking now, is this element, the same element, equals to this position. So here you can see yes it is. Then what we are going to do is we are going to swap the element in that position and the element we are concerned about, which is originally the first element that we encountered, and hence the resultant vector that we get is 1 2 3 4. And what other things we need to do over here is, after swapping the elements, we need to do a swaps plus plus, and this will make the swap variable 1, and we will directly break from this loop. We'll break from this loop and we will go back to our index now, which gets incremented to 2, and from 2, that is from this position, I'll just change this, from this position we are again gonna check is 3 in its right first we'll check is 2 is in right position, is 3 in the right position, is 4 in the right position, and that's how it goes. That means this is the approach we are going to use. We are going to check, we are running one loop to traverse the elements in the vector, and the other loop we are using to find if there is no match between the element and the position. Then we are going to check like where exactly is the match, and wherever the match is we are going to swap, and we are going to accordingly increase our swap variable by doing the swaps plus plus, and hence the value of swap will be increased, and that is something we are going to return at the end of our function. So this was the pseudo code. If you didn't understand this, the basic thing that we are going to do over here is just traverse. The one loop is for traversing and the other loop is just for checking the index. If there is no index, if there is no position match with the element, we are just doing the second loop. That is this loop to check where exactly it matches. Now once we are done with the pseudocode, let's apply this pseudocode over here. What we ought to do over here is, first we are checking in terms of we will speak in terms of position again. Here we are checking, we'll start with 5. We are checking is 5 equals to 1, and we get to know it is not, hence we will enter the else loop over here. Else condition, else condition over here, and the loop will start. It will start from 2, that is index plus 1, and it will go up till last element. And the reason, coming back to why I told over here that we are going only till the second last element, is we are checking the reason we are just going to the second last element is, once we check the element position still here, we will be sure, very sure, that the last element is already in its sorted position, and that's the reason we are just going up till the second last element. Coming back to this problem, we are checking is 5 equals to 1, and we got to know that no, it's not, hence the second loop will start. Coming inside the else condition, we'll check is 2 equals to, we'll get no. We'll check is 3 equal to, we'll get no. We'll check is 4 equals to, no. We'll get is 5 equals to, and that's we'll get it true, and hence we'll find that our 5 and 1 are swapped. Hence what will our array now look like? It will look like 1 4 3 2 and 1, and I'll just write the swap over here, which was currently holding a value 0 but now holds the value 1. After that, we are again going to the second element, that is 4 over here. We are checking is 4 equals to 2 because its position is 2, and we get to know no, it's not equal, and that's the reason we again check for its position is 4 equals to 3, is 4 equals to 4, and we get over here again a swap takes place, and we get 1 2 3 4, and I'm just sorry, this was 5, right? Yeah. So we'll get 5. And yeah, that was it. We got the sorted array, but still, the thing will continue. It will check for 3, it will check for 4, just till 4, not till 5, because second last element. And hence we get the sorted array, and you can see there were only 2 swaps, one for 5 and 1 and the other one for 4 and 2, and that's the reason we'll get swap variable equals to 2. And that is exactly, that is something, that is the answer we are going to return for this test case. Coming finally to the main part, that is the coding part for this logic, and I'll explain you quite easily by looking at the pseudocode and also at the code. You just be comparing the pseudocode and code, and I hope it will become very easy for you to understand this problem. Here we are given the minimumSwaps function by HackerRank, and the argument that they have given is an array, the input array that is passed. Yes. And then we have declared 2 variables, one temp that will be used during swapping, that is our swap logic, that is over here, and the other is swaps, which is initialized to 0, which will hold the number of swaps, and that will be returned by this function. The first thing, we are starting with int I equals to 1, because as I told, we are interested with the position in terms of we are running the loops in terms of position and not in terms of index, and hence we have to do that in the case of array. Then we are going up less than array dot size, and we are doing this I plus plus. Then we are checking if array of I minus 1 is not equals to 1. I minus 1 is not equals to I. That means we are checking. The reason we had to write I minus 1 is pretty clear, because index is always 1 less than the position. And I told you, when we are running our loop variable in terms of position, we need to make sure that we do the compensation in the array index and we write minus 1 over there. So basically we are checking the same thing, is the first element equals to the first index, and if it is not, then only we are going to, that means if it is double equals to, as we did over here, do nothing, and that's the reason we are just concerned with if it's not equal. Now what we are going to do is, from j equals to I plus 1, that is from the just next element, j less than equals to array dot size and j plus plus, we are going to do if array of j minus 1 is equals to 1, then that means just the same thing, the second loop that we are running from index 1 till the last element, and j minus 1 is again the index compensation that we are doing for taking the loop variable as the position. We are doing the swap logic, which is quite familiar, which would be quite familiar with you if you must have done coding, that this is the basic swap logic that we always use. So we are just storing the j minus 1 in this, and the I minus 1 again in the j minus 1 index, and again the I minus 1 will hold the temp variable value. And finally the main thing that we need to do is increment the swaps value by 1, and finally break. That means we are just going to not do any further check whether, if the reason we are breaking is just think it as 2, 1, 3, and just think our positions were 1, 2. So when we check that we got 2 equals to 2, then why will we just go for 3 and 4? So that's the reason we are just going to break once it's done, and we'll directly go to the next index, and for that, once it's broke, we'll directly go to I equals to 2, and that exactly is all with this function. Hence we will get the swaps, and that is to be returned once our loops end. And as you can see over here, the complexity for this problem will be O(n) square, because we are running two loops up till the size of the array, and the complexity is O of n square. And also if I must have forgot to tell you that when I told over here that we'll be going up till the second last element, that is because we are starting with I and we are going less than array dot size. I equals to 1. When we start with array, I equals to 1, we usually go up till equals to, less than equals to array dot size, but we are just going till less than array dot size, and that's the reason by what I mean that is the second last element. And yeah, that was all with this problem, and I'll just do a quick run on this tab. And yeah, all the test cases have passed. So this was all with this video, and I'm not quite able right now to submit the code because I've done quite a number of submissions before this. So I'll be just doing that later on, or I'll just make one more video for that. And all you can do is, if you like this video, please hit the like button and do subscribe to my channel for more such similar content, and also do share it with your friends who are looking for a better optimal solution. And if you also do have a better solution for this, do post your solutions in the comment section below. That was all with this video. I'll meet you in the next video. Thank you.